All continuous probability density functions, and there are literally dozens and dozens of them, have certain mathematical properties in common. We have already seen that the area under a probability density function is the probability of a particular event. Recall that if we are flipping 3 coins, the probability density function provides a visual picture of the probability of all the possible events. Here, the probability of getting 0 heads is 1/8, the area under the probability density function at the value of 0. Here we see the real difference between a continuous distribution and a discrete distribution. We calculate probabilities for discrete random variables at the individual point value of the random variable, such as the number of heads equals 0, exactly 0. For a continuous random variable, probabilities are calculated for ranges of values. As an example, imagine that the random variable is the number of hours studied for the last statistics exam. This is a continuous random variable because time can be divided into continuously smaller parts. For this case, we might want to calculate the probability of finding a person who studied between 10 and 15 hours. This is a range of values and would be written as P of 10 equal to or less than x equal to or less than 15, where x is the number of hours studied. The probability would be the area under the probability distribution between these two values. And importantly, the probability distribution for a continuous variable will be a smooth line demonstrating that every value is a possible value of the random variable. This is unlike the case for a discrete random variable, where we used boxes to represent the possible values of the discrete random variable. We never try to find the probability of a point. It will always be a range. The reason is simply that probability is an area under the curve for a range of values, and a point has no range. We can say the probability that x equals x naught equals 0, where x naught is any value of the continuous random variable. And finally, because a point has no area, we can say that the probability that x naught is equal to or less than x, which is equal to or less than x1, is equal to the probability that x naught is less than x, which is less than x1, where x naught and x1 are any values of a continuous random variable. The difference between the left-hand side of this statement and the right-hand side is that the first one has an equal to or less than sign, and the right-hand side has only a less than sign. Because the area under a point is 0, it adds no probability to include the extra value from the equal to or less than sign. All probability density functions for a continuous random variable will have these characteristics. Each probability density function, however, will be appropriate for only certain types of applications, just as was the case for discrete random variables. We will now look at 2 probability density functions for continuous random variables.